So no slides for today's class. Today's basically just a big code along. I'm just going to be presenting my editor. We're going to be talking about classes. We're going to build some distribution classes. And this is not only going to be an exploration of some distributions a little bit, partly to reinforce some of the logic behind the distributions. But I think mostly the lecture is oriented around classes and what they are and kind of how to use them. This is going to be the foundation of object-oriented programming. It's a term some of you I'm certain are familiar with, and others are have probably heard of, but maybe you're not totally familiar with. Object-oriented is what's called a programming paradigm. So, after you know all the elements of a given language, the question is how do you, what kind of organizational patterns do you implement to organize solutions and to solve problems? So it's sort of a meta pattern of programming. So classes are sort of the backbone of that. There are ways to, I typically don't do object-oriented programming, but in my own coding, I will use classes. And I'm going to kind of show some different ways to use them and yeah, kind of talk about some of the a little bit of the ins and outs of object-oriented. So we don't teach object-oriented programming in prep. We teach what would be considered imperative procedural programming with some, I don't know, some influences from functional programming, but it's, I think, just mostly regular kind of procedural programming. So just so you have a reference about what you've been learning, object-oriented does play a significant role in the industry, but there are some peculiar things about it that are kind of, you might go, why is it that way? And if you ask me, I'll go, I don't know. It's just that way. So there are some peculiar things about it. It's something that you'll need to know, kind of like it or not. We're kind of stuck with it. So yeah, that's just some context for what we'll be going over, and it'll be, today's class will really just be an introduction. OO is a big topic, so it's, we want you to be object-oriented programmers at the end of this, but just to have an idea of what it is, so when you encounter those ideas later, you'll have some foundation of the role that classes play and methods and properties and all that. Let me get my screen presented. So I usually have my text, like my text size expanded a lot for streaming, because I have to stream on this particular computer, I have to stream at a really low resolution. But this is more where I'm comfortable, or more where I'm used to it. I actually make it a little smaller, but is this readable for everybody? Can people see this? Like if I print, yeah, I'm seeing some heads nodding, okay. Okay, if it becomes unbearable or you're squinting or something, don't hurt yourself. Just let me know and I'll increase the text size or something. I don't want anybody to strain. If they need me to do that, I'm willing to do that. Okay, let me get I did not do my sanity check. Oh, this thing gives me all kinds of glitches. Okay. Source. There we go. Okay, good. There's my sanity check. So classes. Classes, in the scheme of things, you all have seen me do this thing about types, functions, conditions, loops. This is a simplification of sort of a schema that I use for approaching new languages. I started diving into C++. I've dabbled in C and C++ for a while, and I actually want to get like actually good at it. So I started diving into it, and this is the schema that I'm using. And this is pretty broad and generic. So these are sort of the topics and questions to answer when approaching a new programming language. And I kind of changed the names to be specific for Python. But really, this should be abstractions. And functions are a type of abstraction. This should be control flow. And then, Python only has one sort of control flow construct, which is if, elif, else, right? So we just call it conditions because we don't really need to catch other things. And then loops are a type of iterator. Iterators or iteration. It's a big topic unto itself, but like I just sort of framed this in the things that we're going to focus on with prep. So the reason I'm putting it this way now is to show where classes fit in this sort of schema of how to learn a programming language. So classes fit with functions in abstractions. We have classes, functions, and we could even consider variables an abstraction. So these are things that make that in some way abstract or obfuscate parts of our code to make them easier to deal with, right? So I'll use functions as an example because I think that's a well-established example amongst everybody here. A function obfuscates the quote-unquote complicated algorithm behind it and gives you a quote-unquote simple interface, i.e. a function call. And if you know how to utilize that interface, knowing how to utilize that interface is what does, what's its name and what are its inputs. Maybe there are, behavioral things that you need to know, like, maybe if you have maybe you have some sort of different kind of result if you pass a positive number versus a negative number. So, understanding it on that level, and then understanding what it returns. Really, inputs and outputs are the central thing to understand with a function, right? So that's what's meant by abstraction. Variables, likewise, you could have, we could have the number 4, but maybe we have a variable num equals 4, and num can equal any number. Maybe perhaps the number comes from an input source or a database or whatever. So that variable it's very simple, but it's an abstraction to the value that it holds. And classes fall in this category as well. So classes, you could think about you can think about functions as logical, not in the Vulkan sense, but in the sense that they hold an algorithm, they hold logic, they describe a process for doing something. You can think about variables as holding data, right? So functions hold logic, variables hold data or state. Sometimes we'll refer to data. It's really a different term, and the terms are conflated, kind of rightly conflated, but we'll refer to an object that has like a definite value at a given time, right? As state or a state, right? So this is an integer that has the state of 7, right? So this is what we mean by state. It's something that has a real existing value. Excuse me. So, okay, functions are logic, variables are state. Classes are groups of logic and state sort of bound together. That's the idea. There's a number of sort of simple ways of using these in terms of just creating convenient groupings of functions that do similar things. And this is actually a way, can be a subtle but effective way of organizing parts of your code base, right? So let's look at an example of using classes like this. So we're gonna, excuse me, sorry for the stuttering. We're gonna use, we're gonna make several classes today, and we're gonna do a little project where, like I said at the beginning, we're gonna build out a binomial and a Poisson class. And we'll build the PMFs and the CDF functions, and we'll save state. Well, we'll look at a few things, but we'll set for a given set of parameters, we'll set a like an expected value and variance, standard deviation, things like that. So we'll set that as state to be saved in the class, and exactly what that means and the implications of that will become apparent when we get to that. But so for now, I'm going to build out some tools in order to build our binomial and Poisson classes. We're going to need things like factorial and combinations functions. So for this particular class, this is going to be what I'm going to call a simple class. And like I said, it's just going to, all it's going to do is just kind of be a group of functions that have a similar purpose. So I'm going to call this class, I'll just call it stats tools. So we use the class keyword, give it a name. You will see parentheses here sometimes. Sometimes you'll see something in the parentheses here. It sure makes it look like a function. The parentheses do not do what they do with a function. This has to do with inheritance, which is not a concept we're going to be exploring in this class. But if anybody's seen code like that, or is asking if this is like an input into the class, it's not. It has a completely different role. Even though, if this were if this were def, this would just be a perfectly rational function head. The parentheses and the name there are for a different role. So we can actually leave them off. In this case, we'll just leave them off. So for this one, we're working our way up. I usually like to work my way backwards, but in this case, I'm just going to work my way forwards from factorial, and we're going to build permutations, combinations, and kind of play around with things like that. So for this, I want to build factorial. So pretty straightforward. Def, notice I'm indented one level, def factorial. And from here, I'm just building a factorial function. This is going to be a factorial function like you've seen us build before. It's not really going to be any different. Well, for I in range 1 to k, excuse me, 1 to n plus 1. No, I can do this. 2. Prod times gets 2, or excuse me, prod times gets I. I was like baking a value here like by accident. It's like a weird mistake that I make. Anyways, and then we can return prod. So that's our factorial function. You know, notice how it's just a factorial function, just like it would be normally, right? So if this were just a regular function, which right now it is, I could print, you know, how I'm a fan of testing. So let's test it, factorial. 4, 5. There we go. Let's save that, run it. So nothing groundbreaking here. I'm going to put it back inside my class. You know, and of course I'm commenting that out, right? Because like anything that, like any line of code that ends in a colon, if there's not a body in the class, it'll throw an error. Notice how my syntax highlighting, I don't know if you can see this, def should be purple and it's white because Python syntax highlighting doesn't know what to do. So, you know, if we wanted to have an empty class, we could just put pass in there, but I was just commenting out. So the pass thing still holds. Okay, so now I have this class called stats tools. I have a function called factorial, nothing different about the factorial function in this case. So I'm going to call the factorial function. Some of you may know what's going to happen. I just realized I don't have Slack up on my phone. Let me get that going. So this is going to say name factorial is not defined yet. Moments ago, our perfectly normal, perfectly good factorial function was working fine. Oops. Which we just saw. So the fact that this is in a class means that Python doesn't see something called factorial. It sees something called factorial as a member of the stats tools class. So in order to access that tool, we have to say stats tools.factorial. This might seem familiar, right? Like we're heading in the direction of list.append, right? Where append is a method on the list class, right? So we're sort of heading in the direction of being able to, being able to build tools like that. I will talk about the difference between a function or a way of, there's sort of, you hear sometimes you hear different definitions, but we'll kind of talk about my opinion on the difference between functions and methods in a minute here. But okay, so in order to access this function, we would do stats tools.factorial like this. So we have to specify that this is a member of the stats tools class. And then this is just going to work normally. Cool. So let's write our permutations algorithm. So we can def permutations. We'll take in N and R, and we'll return. Let's see. Kind of want to put this to y'all. Let you kind of brain this out a little bit. I'm throwing you a curveball here. Some of you may know what to do, but so this is going to be in factorial over n minus r factorial, right? So pretty simple. N factorial over n minus r factorial. Okay. Someday Slack will load, and let me post this. Feel like working Slack? Okay, there we go. Cool. So how would I implement that in the permutations functions? Go ahead and I won't set a timer. We'll just wait a minute or so, see if anybody gets an answer in here. So remember, we're defining this permutations function. So I actually want to do, I'll test it like this. We'll do, we'll say we have 10 trials and we want to choose 2, and this one we'll choose 1, and this one we'll do group size of 2, group size of 1 and group size of 2. Simple tests. Well, I thought I was throwing you a curveball. All right, fine. Yeah, it looks like people are onto this. So we have the invocation stats tools permutations here. So the point that I was going to try to make is that we can't just do factorial like this. If this were, again, if these were just functions, if these are just functions, I could just say factorial n over factorial n minus r, right? But since these are in a class, even inside the class, I have to, just because factorial is also in this class, doesn't mean that permutations knows that it's this factorial function that I'm talking about. So even in the class, I have to say statstools.factorial like this. I have to name the class name like that. In this case, this is always going to give us a whole number back, so we can cast it as an int. And then that way, since we're doing single slash division, we won't get a, what do you call it? Factorial n. Oh, I have that pass over there. So that way we won't get a error if we tried to use this as an index for something. Not that we will, but I don't know. I just think about things like that. Okay. Cool, 10 and 90, and that's what we expect for our permutations. So our combinations is going to be, and I'll write out the formula here. Actually, yeah, I'll write it out here and paste it into Slack. So our combinations is going to be factorial n over n minus r factorial times r factorial. There you go, Slack. Yeah, that. Yeah, I think R is the typical convention in this case, but sometimes you'll see K. You'll see K or R, but yes, they would be the same in this case. Did I mix and match them? No. Okay, I don't think I did. If I if I'm using R and I just like pop a K out of nowhere, it's probably a mistake. Okay. Okay. So I'll give you a chance to work on that, give you a little head start. Combinations. Oh, Tovio used K? Yeah. I think Tovio might use K because they think that I use K, which I used to. And then I was like, oh, actually, R I think is more standard. But yeah, I mean, you actually do see both, though. So I don't think there's like a better way. Okay. So that's just going to be factorial times factorial R. Hey. There we go. Factorial R there. And I'm just going to try to give this a quick beautify because it's kind of ugly. So I'm going to do that. And then in order to allow Python to, or to get Python to allow me to break it across multiple lines like this, I can do backslashes. Or actually, I don't like that. I think I'm going to do, I'll do it after like this. Yes, that's better. All right, so that's a little clearer to me. So let's do combinations. I feel like I'm missing a parenthesis or something. Something silly is going to happen. Whatever. Let the silliness occur. See what I care. Nope, I wanted combinations. Combinations. Okay, there we go. So we should see, again, we should see 10 for this one and 45 for this one. We got 180. Excuse me. That'll be I do this frequently. Yes. Oh, I'm all preachy about parentheses, and I think the past, I don't know, 5 or 6 times I've written this function on stream or in class, I forget the parentheses there. I even know I do it and I still do it. So anyways, parentheses are necessary in that final term to ensure that the multiplication happens before the division. Okay. Yeah, okay, that's fine. So we see 45 here. Remember, the same test for permutations gives us 90, right? Because if we have 10 things and we select groups of 2, we have 90 ways of selecting groups of 2. But half of them involve the same elements, just in opposite order, right? So if I remove, since there's only 2 elements, they can only, the orderings can only be like A, B or BA. So combinations just removes duplicates. It's just A, B, and BA are unique permutations, but they're the same combination. So we just basically reduce those away. That's the idea. And again, that's cast as an int. Cool. Okay. So this is just a simple way to group these tools together, right? This is not, I wouldn't say it's necessarily a typical way that you see classes used, but I don't know. I've done this in my own coding a little bit, and it's kind of nice just if you have a few things that go together and just give them, stick them in a class together like this. Yeah, it can help keep your code organized. This is what, like I said, this is what I would call a simple class. This is not a full-on object-oriented class, but it gives you some idea of what a class is in a very basic sense. You know, we're going to get into some other features that are unique to classes we're about to get into those. But at the end of the day, it's just a container for functions and for state. Now, in this case, I just have functions, but that's okay. We're just going to leave. This will have no state in this particular class. Okay. On to the binomial class. So for this one, excuse me, this is going to be more an OOP class, object-oriented programming-ish class. So for this one, we're going to call this binomial. Yeah, we can leave the parentheses off for this case. And so earlier in this simple class, we just put 3 functions inside of it. And at this point, I want to get us started on a distinction between functions and methods. You've heard us talk about this. Like why is like len list and list dot count L. We call this one a function, and we call this one a method. These two in particular are actually brought up in Python and in other languages as examples of like, why make a distinction? Why is one a function and one a method at all? It's kind of an arbitrary decision in some cases. It certainly is in this case, because len and count do really similar things, right? Len counts everything. Count counts something specific, but they're pretty similar. So why do we call one a function and one a method? And why if these are inside of a class, and in order to access them, we have to do class name dot function name. Why is this a function? Why, if it looks like a method, do I call it a function? You will hear this definition that, well, if it's a member of a class, then it's a method. You will hear people define it that way. I've seen that definition out there, and I don't know that it's, I don't know. I mean, I think it's a little bit simplistic. I think there's something missed in that definition. But yeah, I mean, it is one way of looking at it. The way I prefer to look at it is factorial is a function because essentially its inputs are here, right? This is just a scope in which factorial exists. It's a bucket or a category name in which factorial happens to be a member. It has no, this class name has no bearing on how factorial works. List.count utilizes the value of the list here, right? So I would say the definition of a method over a function is that the method references some state in the class that it's called on. Either references, or in this case it references. It doesn't count, doesn't mutate the state. Append does mutate the state. you could say that it references it too, I guess, but how would we put that? Like it utilizes the state of the object that it's called on. Now, notice you might say, well, what's the state of stats tools? Stats tools doesn't have any state. It's just 3 functions in a class name. That's all it is. And I call them functions because they don't have anything. The way they work isn't influenced at all by the state of stats tools, because stats tools has no state. There's no state in this class. So let's look at a class that does have state. So I'm going to define a special method. It's called init or dunder init. I'm sure you've seen me do this thing. Yeah, I did this when we were talking about lists versus tuples, where I said print dir list, and then I did the same thing, print dir tuple, like this. And in either case, I'm like, okay, let's just look at what's available for lists. We'll just look at the methods that are available for lists, and this will run eventually. Oh, list is not defined, of course. This is not valid code. Okay. So dir will expose all of the methods for a given class here. So, I've done this before. You've seen me do this before. And I'm like, okay, well, just ignore all the things that start with dunders. We're not going to go over all of these. There's a lot here, as you can see. But we're going to kind of get an idea of the sort of role that these kinds of methods play in classes, right? So this is not a normal function that we get to call whatever we want. We have to call it dunder init. Dunder being double underscores. So this is not 1 underscore. This is 2 underscores. This is official Python terminology is dunder init, or dunder, right? Dunder methods. So this is the init function, and this is init is short for initialize. So this is going to be run when we initialize a new instance of our binomial class. Now, if you want an example of initializing a new instance of a class, if I say my list equals list, this is initializing a new list, right? We have a list class in Python. This is also initializing a new list. I'm going to use this analogy because our class won't have a literal form. Using square brackets is the preferred and more common way, and the square brackets are what's called a list literal, right? A literal is an expression that literally expresses what is written, right? So 5 equals 4 is not a literal, but we know it expresses false. False, writing out false in my code, is literally expresses the value false. So this is a literal, right? So when you see something written and you imagine what that would evaluate to, and it evaluates to what is written there, that's a literal. So writing out brackets as a list literally expresses an empty list. So our class will not have a literal form. It's going to look more like this. So if I wanted to initialize a new list class, done, easy, right? I'm going to go out on a limb here and say that this seems rational to people watching this. Oops. Okay, so Yeah, sorry, I just got got a little distracted by the Slack thread there. So this is initializing a new list class, and under the hood, if we look through here, we're going to see somewhere a dunder init that will be the special code to run when the list class is yeah, here it is initialized, right? And I don't necessarily know what's in there, but it has a dunder in it, right? So for this, for our binomial class, let's give some context here, right? So I want to write a binomial class because let's say I want to solve binomial problems, and I want the features of the class tell me to do that. So let's say I want to get the expected value and the variance and the standard deviation of a binomial distribution. Well, there's two things that I have to know in order to determine these. I have to know the number of trials and the probability of success in each trial, right? So if you recall, a binomial distribution is a distribution of Bernoulli trials. Bernoulli is also considered its own distribution, but in most contexts, we just think of it as a type of trial. Bernoulli trial is, I believe Tovio has gone over this, but Bernoulli trial is just an event that can occupy one of two states. The states are mutually exclusive. It can't be neither state, and it can't be like some quantum superposition of both states, right? So problems that can have both states or neither state won't work under the Bernoulli event model. You can reduce a lot of things down. It doesn't necessarily have to be something that has only two states, a system that has only two states. But if you can reduce it down to a set of states that are in one category that we're going to call failure and a set of states in another category that we're going to call success. That's the official language around it. It seems highly connotated, but try to, as you're thinking through it, try to disambiguate the connotation of good and bad between success and failure here, and just see it as like a Boolean, like true or false, which also has a similar connotation. But it's just state A and state B, right? So an example is a coin flip. A coin only has two valid states, two possible states. I mean, I guess you could say it could land on its edge, but it really can't. Not likely to, at least. Or you could say like a six-sided die roll. If you roll a six-sided die, and you could call success getting a 4 or a 5, and then any other roll would be a failure. You could call it that, or vice versa. You could call success getting an even number or an odd number. So your probability can weigh out in different ways, right? So our binomial problem, or our binomial class, is going to be suited to answer or to give us information about binomial distributions. So if I know the number of trials that I have and the probability of success in each trial, I can determine these three things. Okay, so let's have a little problem here. I'll just go with 10 coin flips. So I'm going to say if I flip a coin 10 times, and we're going to assume a fair coin. So that means my n is going to be 10 and my p is going to be 0.5. And then let's just call this 10 flips. 10 flips equals binomial n and p. And I'm just going to call this sum n and sum p. Just to prove the point that, we can call these whatever we want. It doesn't, I'm just trying to, make sure that you don't think like, oh, well, we have to call it p, n or p for Python's sake or whatever. Python doesn't care. So here we're going to take in n and p, right? So notice how function like this invocation is looking, right? I forgot to mention this. I did define this with a capital B. This is a pretty standard naming convention to use camel casing or Pascal casing in object-oriented programming. So when you make a class, it's convention to uppercase the first letter, and if I wanted to call this binomial distribution, I might call it binomial dist, and then I would uppercase the next letter like this. When I'm writing my own code, I do what I want, as should you. And my preference is to use underscore separation or snake casing, as is the official name, because I like it aesthetically better, and I find it easier to read. And I don't know, that's just what I'm used to. But you can follow the convention that suits you best. But I'm just doing this because that's what you'll see. So this is starting to look really function-like, right? So notice we have class binomial, and we have this is called an initialization rather than a call, or rather than a function call or an invocation. It's different than a function call in that we're initializing the existence of an object that is going to, be its own type. This is going to be of type binomial, and we're bringing it into existence rather than a function which performs some process and gives us it probably gives us something back, but it initialized it, or it probably initialized it internally and then gave it back when it returned it, right? So a function may initialize an object and then return it, but this is the actual initialization, right? As list equals list, or list, is the initialization of a new list, right? This is the initialization of a new binomial class. But it does look quite function-like. And there are some things in Python, I believe range, right, where we refer to it as a function, but I believe it is a class. It's like a covert class, a secret class, but it works like a function, so we call it a function. We think about it that way. So here we're initializing this, and so notice my parameters for n and p, rather than being defined here, right? Which if you attempt to do that, n and p, that's you'll get, I imagine you'll get some kind of error. I don't know what error you'll get, but at best it's just not going to work for you. Yeah, it says n is not defined. Yeah, so at best it's not going to do what you wanted it to do. In this case, it really does just give you an error. So notice that our inputs have to be defined in init. Init is the function, since this is the method that will be automatically run when we initialize, right? So this is what's cool, right? Dunder init, we don't need to ever invoke it. We can, and there are times when you will re-invoke dunder init. In this case, We don't ever need to at any point say like, binomial dot like this, right? That's done for us when the function or when the class is initialized. And this is what I mean, right? This sort of is starting to break the rules of what we're used to with functions. We define a function and then it runs when we tell it to run. This is definitely us telling it to run, but it's not quite as explicit, right? So dunder methods are Python's way of saying like, hey, there needs to be some special assumptions and behavior around this particular method. There's some pre-baked in set of features that goes with this particular method, right? In the case of dunder init, it's that it is automatically invoked when you initialize the class. Okay, cool. So notice that the first argument is self here, right? The first argument has to be self. And notice how I'm not passing self. Self refers to binomial. So this is self. This is actually self. You really could think about this as this, right? And this will hold regarding self. This, what I'm about to say, will apply to self in general, except that we can omit this in this particular case. Self refers to the thing on the left of the dot, right? So init is a function that takes in self, n, and p. This is self, this is n, and this is p, right? We just can omit it in this particular case. So what self is also going to allow us to do is refer inside various methods. I just called it a function. I should call it a method. It's a method because it has self. It has, well, it's self-aware. Not really, but it can refer to the class that it's within. So now let's set some state. So init is going to set two properties. So I'm going to say self.n equals n and self.p equals p, like this. So these are going to set two properties in this class. So now if I want to, so let's look down here. Binomial takes in n and p. We get a binomial distribution or a binomial type object back, so 10 flips. If I print, I can say 10 flips because this saved the class dot n and 10 flips dot p, and this will print these values, right? So earlier when I was going over the sort of example, that sort of schema that I go over before every class or before most classes, let's scroll up. So I talked about functions and variables, which we're familiar with. Functions hold logical operations, variables hold data or state, quote unquote state, and classes hold functions and state, right? They hold logical operations and state together. They sort of are bound up together. This is the state that I was talking about. Self.n and self.p. So these are now, you can think about them kind of like variables. And I mean, they certainly look like it here, right? But I get to assign them in this class. I get to say self.n, self.p in here. So yeah, so from here, what's cool is we can, given that we know self.n and self.p, we can determine, I'm just going to do this. We can determine these things and set the appropriate properties for these as well. So for our expected value. Does anybody remember the expected value for how to determine the expected value for a binomial distribution? I'm holding you to Python standards, but yes, I know what you mean. Okay, I'll play fair. Yes, n times p. Yeah, so n times p is our expected value. Our variance is going to be n times p times 1 minus p. And our standard deviation is going to be the square root of the variance, 1/2. Cool. So I actually should have kept those down there. So let's do this. No, that didn't work out. So notice where it says self, I can replace with the object itself. The object is held under the variable 10 flips. There you go. So here's our n and p up top. We can comment those out because it's not that exciting. Our expected value, if I flip a coin 10 times, I expect 5 successes, is here. Our variance is 2.5, and our standard deviation is 1.5811, etc. Cool. So these just live in our class here. These just stay there. And we can actually, this is sort of, I don't want you to go necessarily really doing this, but we could do this. We can reassign these. Let's see what our expected value is, though. So notice our expected value is 5. So what I don't even know what this is. Is this? Oops, nope. Why did I do it in that way? It's 1,000,000, right? So if I flip a coin 1,000,000 times, my expected value is 5. Obviously not. Obviously that's not the case. So just because I changed n here, doesn't mean that everything else was updated. Why should it be? I mean, because it's the right answer, right? But changing one of these isn't gonna rerun Init. And it shouldn't, because if it did, there might be things saved here in Init that maybe changed somewhere else that get reinitialized as some other value that they shouldn't be, right? So it's actually a better assumption to not rerun Init here. I could rerun it and then pass 1,000,000 to it, I guess, just like reinitialize it from scratch, kind of. And of course, I need to pass some p again or whatever, but we're sort of opening up a whole new can of worms, right? So I'm not going to say that there aren't times where this isn't done and this isn't okay. There are times where this is fine. For this introductory, for the purposes of this introduction into object-oriented programming, this is cool, but for now, to be avoided or at least understood with caution, reassigning stateful properties is something you probably want to avoid for now, and it's it's something that you will see, and it's something that's fine in other contexts, but it can get hairy for this reason, right? Because you can change something, and now other things no longer have parity with. You have a state disparity, right? You have one state that doesn't have parity with another state. So proceed with caution. Okay. Something else interesting about, well, let's look at it this way. Let's sort of discover this. What's the value of 10 flips? Anybody want to hazard a guess? It's okay. It's a loaded question. Okay, so I'm sure this is what we were all expecting. It's a rational value to have for 10 flips. It's day 11 lib.binomial object at memory address, because of course it is, right? So that's probably not what we want to see, right? So you might think, oh, well, fair enough. I mean, we didn't return anything from init. So what do we want to? How do we want to represent this? And this is kind of cool. It's kind of cool. We get to decide how this information is going to be represented. So maybe I want to represent it with well, I'm going to use an F string. And maybe I want to do like something like the variance for n equals n and p equals p is, or let's do this, where n equals n and p equals p, variance equals self dot, I need to do self. I forget this. Okay, right? So you might think this seems rational, at least. However, dun dun dun. Here's our error, type error. Dunder init should return none, not stir, right? So it's important to know your init function has to return none. It is fine, by the way, if you just say return none. I don't know why you would. I mean, if you just don't return anything, it's going to return none. So we can't return something from init. I remember when I was learning this, I was just like, wait, but I want that, I want that to be the thing that represents the thing that I want it to look like that. Why can't I make it look like that, right? So if we want to give a representation, we have another method, dunder repr. And oh gosh. I have to do this every time. Is it REPR or REP? It's REPER, I think. I have to figure it out every time. Okay. Okay, it's REPR. Okay. I was like, I'm sure it's REPER. Like that happens every time I do that. Okay. dunder repr is short for representation. So this is how we want our function to be represented when we print it out. So where n equals 10 and p equals 0.5, our variance is equal to 2.5. And I could maybe fill out the rest of these or do something else. There's probably a better way of representing a binomial distribution, but yeah, that's that. Okay, cool. So takeaways from that little excursion, init can't return something. If you're trying to return something from init, I'm gonna guess it's because you're sick of looking at that, binomial object found at RAM address thing, and you want information for when you print it, for when you're doing your tests, which is great. And if that's the case, you want dunder repr here. Cool. Let's have a short break. Let's have a 5-minute break. We'll reconvene at 14 after the hour. All right, we're back. Sorry, I should have got some water there. Let's see. Let me get my presentation up and going again. Okay. So let's build ourselves some other methods. Let's build ourselves a PMF and a CDF. So for this, we're just going to implement the binomial PMF formula, pretty straightforward. So this will be def PMF, and this will take in, so this is where it's going to be a little different. So let's kind of take this opportunity, right? So here we had a simple class with functions inside of it that we would basically define in the same way, other than having to use the function name in front of the other functions in the class. But we basically define it in the functions in the same way that we would if they were just regular functions, not in a class. And these are still functions because they take in inputs, they give out outputs. They don't reference any state. There's no state to be referenced. This function or this class has no, init method with properties like this. Nothing like that. Just functions, right? Here we looked at two super weird functions that are pretty divergent from the functions that we've built before, right? Regular functions. And I keep calling them functions. These are methods. So we looked at these pretty different methods. So we're going to build a method now that we could build as a function. And you may well have built this as a function. So this is going to be interesting because it's going to be methody, but we can compare it to what it would look like if it were functiony. Those are technical terms. Okay, so we're going to take in self, and we're going to take in k. So self and k. So we don't need to. Some of you might be wondering, like, well, why wouldn't we take in n and p? Why wouldn't we take in n and p? Well, we already took in n and p up here, right? When we initialized, we took in n and p so we could do our expected value and our variance and our standard deviation. So we know we're going to need, the number of trials and the probability of success in each trial to do just about anything. So we might as well just take those in right out of the gate. We're only going to need k when we do a PMF like this. Excuse me. So let's bring in, well, let's do it like this. Let's just build our PMF as we normally would. So we'll return. So this is going to be in choose k, right? You'll usually see that written in mathematical language with the tall parentheses with n above the k. So we say that as in choose k. So I'm going to say, so choose is combinations. So it'll be combinations in choose k times p to the k times 1 minus p, oops. Oh, come on. to the n minus k. Okay, so there's our binomial PMF. So there's something wrong with this. Who wants to point out what's wrong with this? Few things. In this case, in the case of a PMF, we usually do call it K. These are really just kind of conventions. They're, should we call them firm conventions? They're not hard, they're not soft, they're gelatinous a little bit. But K, I think, is convention here. I tend to see K more. Combinations is not defined. We would get that error. Combinations is not defined. Yeah, let's run it. So I'm going to save it and run it. I'm not invoking PMF. We'll see if that gives us an error, just doing it this way without invoking it. So let's test our PMF. So let's say PMF. So given that I know I have 10 flips and a probability of success of 0.5, what's the probability of getting, let's just say, exactly 2 successes? Okay, and let's let the errors do the work for us, right? So name error combinations is not defined. Why is combinations not defined? Or how do I fix it? You can give me a line of code where I can fix it, if you know. Cool, stats tools.combinations, yeah. Okay, cool. Am I good to go? Anything else? I know it's a very leading question. Somebody let me know when they want me to run the code and get the next error. So I know I'm making you brain it out, but let's see. N and K are passed, and then multiplied. Not sure this will work. Yeah, so our let's do this. Let's clean this stuff up. Yeah, so N and K are passed in and then multiplied. Huh. Do we have to define PMF and dunder in it? No, we actually don't. So dunder, this is a good question, because I think if I'm intuiting like where this is coming from, this is a worthwhile question, because dunder init is just like additional code that's going to be run. So like when we initialize, like maybe we want to print like, hey, I think you're pretty cool, and we want to set some state, and then we want to print 9 divided by 5 or whatever. You know, like this is just arbitrary code to be executed when, like, on the moment of initialization. It's not, the role that it plays isn't to also make everything else in the function, or excuse me, in the class exist as well. But it's a good question. Okay, cool. So nobody's asked me to run the code. We've got a whole group of people, and nobody said, "Hey, run the code and get the next error." And I'm waiting. run it. All right, thank you. Do it. Okay, cool. So let's run it and get the next error. Wouldn't it be funny if it just works and it doesn't give me, I've been building up to this error and it just doesn't give me an error? That'd be great, right? Errors are my friends when I want them to be. Okay, so name error, name in is not defined. Why is in not defined? See, isn't this nice? Isn't this error nice? It told me what was wrong with my code. In is not defined. Should NP be called self? Oh, okay, sorry. Yeah, somebody got it. I was reading through. Yes. Yes, so this is correct. So in order to rectify this, like in as named, as shown, and P as shown don't exist in this scope in that way. N, and I'm not talking about self.n, I'm talking about n, just n. It's different than self.n. N came in as a parameter in init, and then init was over after we were done initializing the code. And then just like any function, its parameters go out of scope and get cleaned up and they're gone. So those are parameters, and like any parameters, local to the function that they're, or to, excuse me, to the method that they're in, right? So those are just local parameters like anything else. So in order to rectify that, we have to say self.n, self.p. We have to do that everywhere. I'm just gonna, I'm gonna save myself uglifying this already fairly beautiful code, and I'm going to say n equals self.n and p equals self.p. This is kind of a common thing. Well, at least in my code. I do see it in other people's code as well. Like it feels sort of, I don't know, like I always use the term like juggling, like where it's like, you know, put this here and take this and put this here and there. And it's like there's just sort of this like swapping thing that feels redundant and a little unnecessary. But it's nice because it's nice to not have to type out self.n and self.p when you just want to use NRP or something. So it saves you a little bit, kind of beautifies your code a little bit. So, and let's just do this. N and P. We'll do this on a line. So n and p equals self.n and self.p. Okay. Wait, before you see it, is it going to give me an error? Too late. Doesn't matter. Python will tell you if it's going to give you an error. That was a trick question. Okay. Cool. That's our binomial PMF. So for this, let's juxtapose this against like a PMF function. So if this were a PMF function, obviously there's no self. I should probably call this binomial. Binomial PMF. And we'd take in n and p. And then no need to do this. We'll still use stats tools, stat combinations, right? So this is the format in which we're used to seeing this, in which we're used to kind of writing this. And I'll just juxtapose this against this PMF method. The reason this is a function, again, I'm just going to repeat this. This is a function because it takes in inputs and it gives us an output. You might say, well, isn't that what PMF, binomial.pmf method does? Yeah, I mean, that's part of what it does. It takes in inputs and it gives us an output. But it also, as part of its process, it references state, internal state. It references this internal state. In this case, that's all it does. It just references it. It doesn't mutate it. I'm not going to dive into shared mutable state issues. There's this thing you'll hear about. Someday you all will get into functional programming, and you'll hear about the evils of shared mutable state. Imagine two methods that both mutate the same state. Now, this is just a reference to the state. I don't really have a good analogy for this, so I'm just going to kind of do this. If I just said, I could absolutely say self dot p equals hello, and then have another method somewhere that says self dot p equals or ooh, this is even better, plus equals 10, or how about something nice and confusing like self dot n or something, you know. So this is obviously going to create an issue, and it's particularly hard to spot because it's not going to be in the same method. I might have a method somewhere that changes state in one place, and then I might have a class with 30 methods in it, and then 10 methods later I have another method that mutates the same property, maybe purposefully, maybe without knowledge of the previous one's behavior, right? And now you have no single point of truth, right? Like now you have what's probably going to quickly turn into a very confusing mess. Sometimes you'll hear the phrase shared mutable state is the root of all evil. And it's because, many a developer have spent many sleepless nights chasing down silly problems like that and finding shared mutable state to be the problem. So I'm not building these in a way where we're mutating state. I could do something like self dot, and this, yeah, actually, no, let's do this. Self dot pmf dict equals a dictionary. We'll just initialize this empty dictionary. And then I could say self dot pmf dict sub k equals this. And now we have, just like append is a mutable method on a list, we now have a mutable method where we're utilizing a dictionary for it, but we have now a mutable method that every time we call it with a different k value, we'll mutate a property in our binomial class, right? So now, I'm stretching this a little bit. I'm not sure that this is really a great way to do this. I think returning really makes sense here, because you're just asking the question like, hey, given those previous things that I said, a given value of n and a given value of p, what would be the probability mass function for this given value of k? And you're just kind of asking that question. Given that I know these two other things, here's a k value, what do I get back? Makes sense to have it as a return to me. But you will see things like this. So if this, like I said, it'll put the PMF value in the value for the key of k. So the question is, what happens here? What's going to happen here? Actually, we'll put this one to you. What's this going to return? You got an answer? Any dissenters? Yeah, so this is going to return none. Why? Because, well, I took away the return. I could do something. Oops, 10 flips is, oh, I commented out the Cool. I was trying to clean up and nope, I gotta do that. Okay. So that gives me none now, right? So now I have to, okay, so this is the invocation, and now I have to do, if I want to see the result, I have to do and let's just do k. We'll say sum k equals 2, and we'll pass in sum k. So 10flips.pmf is the dictionary. I want to see the result of sum k, so I'll say sum k. Does this? Yeah, this doesn't seem simpler to me. Let me put it that way. But patterns like this are somewhat normal, somewhat like this. I don't want to totally throw object-oriented programming under the bus, because there are ways of building really robust, really fine, totally rational, excellent programs with object-oriented programming. But I'm showing you this pattern because you will see it. There are places where this kind of behavior is the assumption, rather than having a function that returns something. I don't know why. Not sure why this is better. In a given case, it might be preferable, but as a rule of thumb, I'm not sold on it. But I'm, people disagree. So you will see weird patterns like this. If this doesn't totally make sense, give it some time. To me, it just feels like I know what this is. I know object-oriented programming, and I feel like there's a lot of stuff just kind of moving around, and I just wrote this code. So don't worry, it's normal. The confusion is normal. Okay. So I'm going to turn this back into a return. Okay. Let's write a CDF as well. So CDF is going to take in, CDELF is going to take in and p, or excuse me, it's going to take in self and k. We're going to extract n and p again, like this. ACC. The great thing about a CDF, any old CDF, you can just write an accumulator pattern for I in range. For I in range. Okay, very simple. ACC plus equals self dot PMF, and we'll pass in I for k. So notice, I think this is obvious, but I didn't. I think I also forgot to say it. I don't have to pass in a value for self, right? Self in this case is tantamount to passing it in. So the thing on the left of the dot is, you could think about it as the first parameter. And because we define things this way, Python does think about it that way. Even though during invocation, it doesn't look like it's a parameter at all. Look at the definition, it's defined as a parameter. So Python will doesn't call it a parameter, but, well, sometimes it does actually. In certain errors, you might import something from a library, a function from a library, function or method from a class, from an object or a library or something, or a module. And since it's a member of a module, that module is a class. If it takes one argument and you don't give it any, Python will give you an error that says this method takes 2 arguments. And you have to know that the first argument is the class. and the second argument is what you would think of as the argument, right? So, shoot, rather than I could just demonstrate this. It's right in front of me. So much easier than describing it. Key error. Right, I'm back to returning. Let's do that. Sorry. Okay. Oh, right. I'm like, why is this not giving me an error? We'll invoke CDF. I'm gonna do 8 or something. Type error, missing one required positional argument K. So okay. So I guess in this particular argument, it's actually telling me that it requires one positional argument, but okay, it's like it's doing this just to put me in my place, which okay, maybe that needs to be done. So this says one required positional argument K. I wonder if I can get it to do this. I wonder if it's just if I do this. Oh my gosh. I wonder if they fixed that problem. That'd be nice. Anyways, it may be the case that you will encounter an argument like this where you have a function or a method that takes in one thing here, and it will say something to the effect of missing, oh, this is a different error. Anyways, sorry, I'm getting this confused with a different error. Yeah, okay. I've chased that dragon as far as I'm going to chase it, but yeah, there are times when just know that there are times when in errors it will sound like there's more parameters than there actually are. Maybe I'm going to try this one more time, see if I can get it to give me that error. Yes, okay. I did it. Okay. I got the error that I was looking for. Okay, so CDF takes two positional arguments, but 3 were given, right? Notice how it sure seems like I gave it 2 arguments and it takes 1, right? This sort of should say it takes 1, but 2 were given, and that's because it thinks of 10 flips as one of its arguments. Okay. Side quest complete. Cool. Yeah, so that's a binomial, simple binomial class, right? So this particular lecture always goes really differently. Always like giving it. Sometimes it seems like we fly through this in like 30 minutes. I think it was good to we took our time with this, which I prefer to do. So we're not going to be able to get through a PMF class without just like hammering it out and me just kind of doing it. And it would be more or less kind of a copy of this with a different PMF and some different properties, but structurally it would just be an iteration on this theme. So I think it might be more useful to pivot a little bit and do sort of a recap of what this is, and then maybe if we have time. So I know it said I think it said we were gonna talk about errors and tests today, and honestly those topics are in there because this lecture almost never goes this long, so I needed filler stuff. So we can touch on those if we have time. Oh yeah, I'll post my code. I'll post the whole thing. Slack has to completely reload. Okay. There we go. Okay. So let's do a recap. Classes are containers for kind of just like arbitrary code, including function definitions. They have the special ability to set and retain state internally in the form of properties, which bear a resemblance to visual or to variables, not only visually but in the sense that it's just like, it's a point in memory that, or it's a some part of your memory that just points to a value, but that value is associated with the class. So it's similar to a variable in that sense. In this example, I before I had this, well, I still have the PMF dict laying around, but in this example, this particular example, I'm setting state in init. You can set state in any method in here. I believe you can just set state arbitrarily, like just self dot whatever. Just in the scope there's a way to do that. I think it's considered a bad practice. I never do it just because, I don't know, it kind of looks weird, but it feels messy to do that. But so I just don't do it for that reason, but there is a way to do it. Not that you should really chase that down. So properties can be set inside of methods, we'll just say. In this case, I'm only doing an init, but we could do that in any other method as well. Properties like variables can be read. Here we're reading values of properties and saving them into variables local to this function, method. They can be written to like variables as well. So we could override them. I could say self.p equals something else. If I do that though, just like a variable, it doesn't magically recalculate everything else that was based on that variable. So a lot of times you're setting state in a way that, and especially in this example is true, all the state is relative to each other, right? So if I change one value, it's no longer going to have parity with the rest of the values that were set relative to it before it changed, right? So you have to keep that in mind. There are object-oriented workflows where the default way of, and some people will just paint this as like, this is what object-oriented programming is. I think it's a little reductive, but there are some object-oriented programmers who say that as well, say this as well, that like the idea is the assumption rather than returning variables is often to set state instead and mutate state. So you're constantly setting and mutating and saving state. And I got to say, on paper, it sounds really cool. There are ways of making it sound really cool because it sounds like, oh, I'm going to have this like sort of stateful snapshot at any given moment. And it can, I really don't like programming that way. I can do it. It was a big lift for me, but the way I prefer to approach object-oriented programming is to set state kind of cautiously and to avoid mutating state as much as I can. So I think, oh, I can mutate state here. I don't go, well, then I will. I go, but do I need to? Is there a way that I could do a transform instead of a mutation does this variable really need to stick around, or does this property really need to stick around, or can I just return it, use it where I need it, and then get rid of it? Often the latter is preferable to me. So, and this sort of gets back into, there was a question asked a number of classes ago, and I've brought this up a couple times, and I don't mean to put the person who asked it on the spot. I think it's a great question that kind of gets at some kind of philosophy of problem solving that a particular way of looking at things that I really like, which is, the question was on the lines of, well, if tuples are immutable and lists are mutable, why ever use tuples, right? I mean, mutability is powerful, but I think we explored this pretty well when we explored tuples during the class with tuples, and we saw how that, well, even though tuples are immutable, we can actually recuperate all of the behavior of the mutable methods with concatenation, slicing, and indexing. So those can look a little funny, but they're not that hard to learn. And once you learn them, they're really powerful, and you now haven't lost anything. And you have a type that has a smaller footprint in memory, is more easily managed in memory automatically behind the scenes, and or at least theoretically. I mean, in practice, they're pretty analogous, but and something that when you pass it to a function, you have a guarantee that that function can never ever change the size or the values in that tuple, right? So you have automatic copying, right? So you never have to worry about like, oh, did I mutate this in the wrong spot, and now I just totally hosed my list that I've been building up for all this code, and I didn't realize it, and you got to go chase down where did I forget to list.copy, and you don't have to worry about that with tuples. So opting into the power of mutability, it's fine, but just do so knowing that power comes with responsibility, right? You have to fully manage all the implications that mutability has, which aren't obvious unless you spend some time, or somebody like me says, hey, this isn't bad, just proceed with caution. So I think a lot of code that's based on the idea of like pure object-oriented programming, where you're always setting state, you're always mutating state, it's taught in a way, like people learn Java and it's like it's their first language, and Java is you have to do, like, Python's an object-oriented language because it has object-oriented features. Its types are classes under the hood, but you can just like program in it. You can just write procedural code in it. You can do functional programming to a significant extent. You can just it's just kind of like, oh yeah, you just do whichever paradigm that works for you. It's pretty relaxed. Java, it's like you can do those other paradigms, but it is all and only explicitly within the context of object-oriented. When they say Java is an object-oriented language, it's like, it's not like, yes, it can be. It's like, yes, it is. And if you want to do something else, you have to work around it being an object-oriented language, which you can do, and people do that. But so a lot of that code comes from this idea of like new people learning object-oriented programming first, and not fully understanding the ramifications of just laissez-faire mutability. So I know that little spiel is a lot. There's a lot going on there. It might not all, I'm sure not all of it's landing for you yet, but I want to go over this now because the DSI will get into object-oriented programming. I hope I didn't like taint your opinion of it. I think it's a fine paradigm. It's you can write really good code and really bad code in any paradigm. It's just you have to be aware of the pitfalls, right? And the pitfall with OO is that mutation is powerful, but potentially dangerous. Dangerous in the sense that it can lead to like weird corruption of data where you have disparity. But when you change something and now that change should propagate to other things and it doesn't, well, if you want it to, then manage it. Then you're fully responsible for having that propagation occur correctly, which you can do. You just have to approach it understanding those implications. So when you get in to the object-oriented material and the DSI and after the DSI and start diving into it, hopefully you will remember me talking about these things, and some little voice will say, wait, do you need to mutate state there? You can, but does that mean you must? Does that mean that's the only way you can do it? And if you think about it, if you give yourself 10 seconds or a minute to think about it, most often the answer is, no, I don't need to do that. I could just do something simpler that will probably be easier to manage in the future. So anyways, go in with your eyes open and you shall do great things. So I just talked away our remaining time basically. Yeah, so I think we can just wrap up there a little bit. Oh, looks like we got a comment. If you're writing packages or programs that are used by other programmers that can do bad things to your objects before passing them back to your programs to continue processing on, immutability is mandatory to preclude that. Yeah. Yep. That's what that comment said. That's what I think. Yeah. So mutability powerful. This is just literally a different, like an order of magnitude different view of that same topic of like, lists are powerful, tuples are simple, but if you think about it, they're kind of the same. And the implications of having something that's simple is kind of awesome, so don't underestimate a simple way of doing things, and don't necessarily like throw away complicated ways of doing things. There are times when mutation's great. Okay, I'm starting to repeat myself. I shall release you. Yeah, sorry we didn't get to error handling and stuff, but yeah, I think it was good to. I actually want this lecture to go this way, to like have enough time to dive into object-oriented features. Yeah, so cool. Let me stop the recording.